Hi, I'm Judy Preston, and I work for the Long Island Sound Study. So I'm about 4 hours south of here on Long Island. And the reason why I'm here is because I have a connection with UVM, with Jen Colby, who is working on grant monies from a grant that I'm helping to coordinate. And the whole idea of the grant is to reduce nutrients, particularly nitrogen, that's reaching Long Island Sound. So Jen asked me if I wouldn't like to come and talk about why that's an issue. I mean, this whole grant, which started in 2015, a 5-year grant, $10 million. It was a really significant effort on part of a small group of nonprofit organizations that came together and got this money through NRCS, Natural Resources Conservation Service, to work collectively, collaboratively, and imagine that in New England. So all the New England states that are in the watershed, which is all of Connecticut, a good portion of western Massachusetts, a little bit of New York, and both New Hampshire and Vermont in the Connecticut River. All of that is eligible for funds for this program, with the idea that if you start at the source, these are all working land, so it's agriculture, it's forestry, and there's also a component that's looking at restoration of floodplains. That's kind of a shout out to resiliency after all the storms that you guys got in Irene. I live down on the coast, and when Irene came, it skidded past us, and then of course went up the Hudson River Valley and just blasted you guys. Then we got Sandy, or we had Sandy, so we all got it in some capacity. So I'm going to talk about Long Island Sound because it may seem like it's super far away, but the reality is everything that we're doing right now, even today we're in the watershed, has the potential to have an impact to Long Island Sound. And since I work for the collaborative organization called the Long Island Sound Study, I'm really interested in helping people up the watershed have a better sense of why what people are doing is important. So I put this photograph up here because I think it is a spectacular photograph, and actually a high school student took this. Oh, wow. It was taken in New Rochelle, New York, on the banks of Long Island Sound, and it's a really hopeful, perfect example of the life that's coming back into Long Island Sound, and it's connected to just editing our fishing practices in terms of feeder fish. These are all bunker here, menhaden. And so we're seeing whales coming back into Long Island Sound with gusto, which is incredible. I mean, I've lived near the Sound for most of my life, and the fact that we're starting to be able to see breaching whales as well as a bunch of other species is really hopeful. So that's a positive thing. So we are somewhere up here. I just spent the night with a friend in.
You did really well. Maybe we're close.
Yeah, it's somewhere. I know we're not here. So, and I came up from down here. So all of this is in the watershed. So potentially everything and anything that happens in that watershed can affect Long Island Sound. And I'm going to explain that a little bit better. Almost 17,000 square miles, 10 million residents. That's the really important thing. 10 million people who live in the watershed. And there's a lion's share of those people that are concentrated on the Connecticut coast and on the north shore of Long Island. So all of this is the watershed. And you might say, again, what's the connection? What does this all have to do with where we are right now? Well, this was a really great example to us working on Long Island Sound about the connection to watersheds. Because when Irene came and went, it wasn't a big deal for us along the coast. It was a storm, but we didn't think a lot of it. But we got all of the newscasts that show all the things that were happening, and I have some friends that live in Vermont, and it was just devastating. And a couple of weeks later, this is what happened on the coast. I live right here. So every morning when I go to work, I pass over the 95 bridge on the way over to the Thames River. And every morning for a couple of weeks, I could look over the bridge and see this roiling, and there were docks and there were tanks and there was all kinds of debris that was just churning past here. And this is the jetty that's out at the end of Lind Point here, and you could just see this incredible amount of sediment, and that was Vermont, basically Vermont, New Hampshire, those places that were hammered. All of the sediment that was leaving here, which was agricultural fields and everything else, ended up in Long Island Sound. And this is interesting because the tide was headed in from, the opening to Long Island Sound is over here. So you could see the tide was bringing the plume this way, and then when the tide shifted, that plume would go this way. So this is of interest to people who study Long Island Sound because this was an extraordinary amount of sediment that was being pushed into Long Island Sound. And there are some folks from Wesleyan University in Middletown who have been studying this to see just what was the impact of that. But it was a fantastic example of saying, we are not isolated, that everything that happens within a watershed has the potential to impact. And of course, sediment is one of the major ways that pollutants get dumped into watersheds and into waterways because it attaches to the soil and makes its way down there. And what's interesting is that, I drive over here and see this incredible amount of sediment, and then I drive over the bridge on the Thames River, which is another large river in Connecticut, and it was clear. So it was just interesting that this was really emptying out the upper watershed. So as I mentioned, pollution impacts often comes in the form of sediment, which is why there's such an emphasis on erosion and sedimentation control to try to keep sediment where it's supposed to be, because not only does it smother life, but it also brings with it a lot of pollutants. So that can be excess nitrogen, which is what we're really concerned about, but also toxins and contaminants, all of those things. And it can accumulate and suffocate. It reduces the ability of underwater life along the shore to grow because it takes the sunlight away. It basically covers everything. But it also, and probably more importantly, actually smothers the organisms, the scallops. We all love scallops. I love scallops. So it's important that we keep track of how you control not only sediment, but the pollutants that are arriving on the sediment. So a little bit about Long Island Sound. How many people have been? Everybody's been. Okay, good. So you have a sense. It's ocean. It's protected ocean because an estuary is by definition a protected area where fresh water from an upland makes it into a mix of ocean water. So it's usually the concentration of salt is less. So here's outside ocean. This is Atlantic Ocean. 27 parts per thousand of salt. By the time you get in, well, actually no, this is about 35. This is about 27 here. And by the time you get up some of the major river systems, it goes down successively. And that dictates all of the organisms that live in that area. And it fluctuates as the seasons go on. But this is an unusual estuary because it's on its side. It's elongate. Most estuaries are at the mouths of rivers, and they just the river widens, it opens into the ocean, and that's the estuary. This actually has it's elongate, it's got two entrances and two exits. This is the problematic one. This is the Hudson River and the East River that comes in here, and this is New York City. So this places a lot of pressure on the waters of Long Island Sound. And then this is what's called the race. This is the deepest area, is about 350 feet. This is where historically this was a glacial lake. So this was all connected. And as the glaciers moved away, eventually this dam broke, and that's why it's 350 feet deep. This is where we get really strong currents that help flush Long Island Sound, bringing in water from the ocean. So, and of course, all this is glacial deposits here. So 21 miles at its widest point in here, 113 miles long, a fairly large square mile area, and 600 miles of shorefront, but it's not all beaches. In fact, most of the beaches have been reserved for the Long Island, North Shore of Long Island. A lot of what we have in Connecticut is either bedrock or, unfortunately, shoreline hardening. We do have beaches. It's not like we don't have any beaches, but a lot of it is privately owned land, and particularly as you get closer to New York, it's really expensive real estate. So there's people who have a lot of money and can afford to live and survive the taxes of being right on the water. So there's lots of interesting issues, and I do outreach and education to people in Long Island. So to me, it's a challenge to, if you're trying to talk about Long Island and you want people, Long Island Sound, you want people to get excited about it, it's really helpful if they can get to it. So that's a big issue. The other part of this is that any estuary healthy, even a less healthy. And this is actually a pretty healthy estuary considering the impact of the population that is there. Supports tremendous amounts of species. Birds, migratory birds. We have birds that come up the east coast of the continent of North America, and they'll come over Long Island, and they may rest here. They will come over Long Island Sound, and they will bifurcate. Some of them will go up the Hudson. They often follow rivers. There's a whole group that will go up the Connecticut River, actually the Connecticut River over here, and then some of them will go up to the Cape. But it's very important that they have areas to rest and feed, both coming and going. So this spring, which we are going to get spring, the birds will be coming back, and they will be looking for marshes, salt marshes, and as you go up the rivers, they'll be looking for brackish, where there's a little bit more freshwater influence. Really important areas that we need to maintain so that these species can survive. And the birds, particularly osprey, are relying on a really healthy fish population. And that was that original photograph, and I'll show you some more of that. So we still have tremendous fish resources. The tricky part is helping to manage between commercial fisheries, recreational fisheries, and wildlife. And that's true for any estuary. So I like to call estuaries the gardens of the sea, in part because I do a lot of speaking. I run a program called the Coastal Certificate Program, and it's working with master gardeners with their interest in gardening and landscaping to try to reduce nutrient inputs into Long Island Sound, because excess nitrogen is a big problem. And that's, this is a coastal system is what's called nitrogen limited, which means ordinarily it has a fixed amount of nitrogen to it, and it's evolved to live with that amount of nitrogen. Then we have 10 million people in the watershed come in, and we have septic, and we have sewage treatment, and we have a lot of nitrogen that makes it into that system, and that affects how the system responds. But very important, 75% of America's commercial fish, 80 to 90% of the recreational fish rely on estuaries. And that's because of the rim of really important marshes that provide nurseries for fish. So all of the fish that are out in Long Island Sound, and ultimately that migrate, some of them migrate out into the ocean for parts of their life, are relying on the ability to come to healthy salt marshes in order to be protected from larger predators and also get the resources that they need. So here's the connection. We could say that, okay, this is the Connecticut River, and we're up here somewhere in the watershed. Watershed isn't always an easy concept. It's basically all of the area that captures water that goes to the same place. So the problem that makes it difficult, that everything that's within this watershed that's defined usually by elevation, all the water that falls in this watershed is going to end up here. Problem is that there are many different scales of looking at watersheds. So you can have little tiny watersheds, and you can have the scale of the Connecticut River. Doesn't really matter because it all ends up in the same place ultimately. And that's important because what happens in the watershed matters. So land use, how we develop our land, how we work in our fields, how the types of nutrients and the amount of nutrients that we put on our land is going to make a difference. And I'm sure that people argue, because I've heard it before, that, come on, even if we had an oil slick in Vermont on the Connecticut River, you really think it's going to hurt Long Island Sound? It's like, all right, so that drop of oil that ultimately gets it all the way is probably not even going to make it to Long Island Sound. But the important thing is that this is part of a much larger system that supports this incredible web of life. And so when you start compromising anywhere in the system, you compromise the ability of the whole system to do a good job. And 70% of the fresh water that mixes into Long Island Sound and makes it an estuary is coming from the Connecticut River. So that's a big part of what we're talking about here today in the watershed for the Connecticut River. I would also mention too, do you guys get shad herring, river herring up here?
I have no idea.
Yeah.
We have shad.
Yeah, I was going to... I was going to check and see how far up they migrate. Well, shad is a good example of a fish that spends most of its life in the open ocean, getting resources that it needs, and it comes back to freshwater areas to spawn. So these fish...
No, we don't have a continuous access for fish to be able to come.
Well, that's true. You have dams. Yeah, that's true. But there's a lot of the Holyoke Dam, which is in Massachusetts, allows fish to go past. And I don't know how many dams there are up here, but you've been doing a great job actually of removing dams, and that's been that's very exciting. But the life history of these is a really good example of how what happens in the land matters and how the ocean resources can infiltrate and become an important part of the food web of inland. So regardless of how far these guys migrate, they're a really good poster child for ocean resources that will come up the river to spawn. They will lay a bunch of eggs, and just like nature does everywhere, they'll lay more eggs than they know are going to survive, and that feeds a bunch of animals. And those that succeed will start the cycle again in terms of migrating back to the ocean. But they also, some of them will die, some of them will have been mature enough and die, and they will feed otters and bear and any number of mink. So they become a part of the organic resources that are made available from ocean. And that's true the other way, because all of the organic material that's coming down this watershed from our woodlands, from our woody debris that ends up in our waterways, from what remains of different species that become a part of that mix, including insects, that washes out into Long Island Sound. And that too is a source of nutrients for the species that live in the Sound. So it's this, everything's connected kind of thing. And the thing that's really interesting about this story is that freshwater mussels, which are becoming increasingly rare, and in fact, in North America, in the South, we have one of the highest diversities of freshwater mussels. And you say, well, so freshwater mussels, we don't really eat freshwater mussels, but they're extremely important in the ecosystem of a freshwater aquatic system. And you might wonder if you've ever seen these things travel. They're in the mud and they travel, inches a day. That's a good day for a mussel, a couple of inches. And you think, how on earth do these things expand their populations? How does that work? Well, this is a great example of the adult mussels will send out their young, their larvae, into the water column. They'll float on the water column, and along comes a migratory fish. And those larvae will float around until they either get sucked in from the filter feeding of the fish, or they can find the fish and attach to the gill. That's their ride. So they end up going wherever the fish goes, and as they mature on the gills of the fish, eventually they will drop down and they'll establish a new population somewhere. So there's a really important relationship between these two species, which is to say that if we start losing the fish, either from dams or from excess fishing in their winter habitat, or for whatever reason, overfishing, then we also lose mussels. There's so many attachments like that in nature that it's a really good example of, can you make those kinds of connections? And even if you can't make those kinds of connections, can you trust that there are lots of connections that are important to make? So, and of course, this population becomes critical for the osprey population. And we've seen that. The osprey population back in the time of DDT, which is getting beyond the memory zone of people. These birds, we got down to about 10 birds in Connecticut. And now we have hundreds of osprey, which is really exciting. So when I talk to audiences around Long Island Sound, I try to get them excited about what they can do to protect Long Island Sound, whether they live on the shore, whether they live in Vermont. And part of that story is a leap of faith to say that it's not just about what we can see, because frankly, we can only see the surface. If you look below, there's a whole suite of organisms that you just got to kind of trust the people who took these photographs, because they weren't me. That there's a whole suite of life under the water that relies on healthy water coming down the watershed. So even this, I love to point this one out because I think that looks very tropical, and it just amazes me that this is on the bottom of Long Island Sound, and there are big populations of these northern anemones. Eelgrass, which is being used as an indicator right now. We used to have eelgrass all along the coast in Connecticut. It can only survive in waters that are clear enough and clean enough so that it can get the sunlight that it needs to live, like any green plant. And we have seen it go from all the way at New York to now only in the last quarter of the eastern part of the Sound. So part of looking at protecting Long Island Sound is also looking at how do we bring that species back. That could be our indicator. If we could have healthy eelgrass beds under the water, that could be a really good indication that we're doing the right thing. So all of these organisms are part of that ethereal life that's underwater that most of us won't see, but we can trust that if we do the right thing, these things will continue to survive. And that, of course, gets us to, okay, what is the problem and what is happening in the watershed? And, you know, we're almost 9,000 tons of nitrogen that are coming into Long Island Sound, and that's from stormwater runoff. So that's what's coming off the land. And to be honest with you, the biggest contributor of nitrogen is just flat out the density of people who live along the coast. So that's not your problem here, clearly. But there's been a lot of work in the last 5 years to really upgrade. I mean, that's huge amount of money, as you can imagine, and not a very sexy project to do in terms of spending taxpayer dollars. But boy, does this make a big difference when this can be fixed. Septic is a big issue. I have septic where I live. Most of below 95 on the shore have septic. It's just an older style of getting rid of our waste. Sometimes it works, sometimes it really doesn't. Agriculture, you know, obviously agriculture up here is a much more important and stable part of your economy, and you have far more farmers here. Connecticut has really been decimated in terms of its farming, not only because of sort of the loss of land, but the loss of real support. I'm happy to see that I think some of that's changing, and maybe you guys see this too in terms of younger folks that are coming up and saying, yeah, I want to do this, and I think that's really exciting. The other thing, of course, is even just automobile traffic, of which we have a lot. If you think of the corridor between New York and Boston, that's 95, goes right along the coast of Connecticut. And all of the exhaust that comes out of these contribute to atmospheric nitrogen. So we also have atmospheric nitrogen. We have nitrogen coming from this source. This isn't nitrogen so much as it is fecal coliform, but it's a contributor. I always like putting it up there because people with pets often don't feel the need to pick up after them. And this is the one that I work with a lot, which is sort of the low-hanging fruit. You know, we don't need to be fertilizing our lawns as much as we do. So all of that becomes the total initiative that says often we don't see this damage because it comes off the land, it goes into this stormwater drain, and often this goes right out directly into the receiving waters, either a stream that's going right to Long Island Sound or going right out to Long Island Sound itself on the coast. And it's not treated. So, and that can lead to fish kills. So the process of hypoxia, I'm not going to go into great detail on this, but basically, again, if the system is limited and you put